Greetings, students. This is Mr. Torgerson. Today I will be discussing with you the Algebra 2 Semester 1 review for 2017-2018. Question 1. What is the value of f of negative 1 in the quadratic function? We will substitute negative 1 in for the x to evaluate the function at negative 1. So f of negative 1 will be equivalent in value to negative 2 times the quantity, negative 1 plus 3 squared minus 4. We will evaluate the parentheses first. Negative 1 plus 3 is 2. So this will be negative 2 times 2 squared minus 4. Next thing we'll do is the exponent. 2 squared is 4. So this will be negative 2 times 4 minus 4. And finally, we will evaluate the multiplication and subtraction. So negative 8 minus 4 is equivalent in value to negative 12. My answer is negative 12. Now, we can use the calculator to assist us here on this question as well, using the keys of the calculator. Remember, the negative key is next to the decimal. So you'll use this key when we're typing in the negative 2. So I'll use negative 2 times the quantity, parenthesis, negative 1 plus 3 squared is next to the 7, or I can use the caret key with the exponent of 2, either or, minus 4. This should be negative 12. Question 2. What is the inverse of the function f of x equals 4x minus 9? For inverse functions, we substitute the x and the y values, or in other words, we replace x with y and y with x. We can do this with a table or with a function. As this is a function, we'll use the function. So right now, this is equivalent in value to y is equal to 4x minus 9. The inverse function will be equivalent to value to x is equal to 4y minus 9. I will solve this for y by adding 9 to both sides. So x plus 9 is equivalent in value to 4y, and then dividing by 4. The inverse function notation is f negative 1. So negative 1 here signifies the inverse of f of x is equal to, in value, x plus 9 divided by 4. Now I can divide these individually, or I can leave them as a quantity. Since the 9 is not a multiple of 4, I will leave it as a quantity. However, if that 9 was a multiple of 4, I would probably divide it and write it as the integer value. So, for example, if that 9 was a 3, it's not a 3, if it was a 12, I would write it as 1/4 x plus 3 if that 9 was a 12, because 12 divided by 4 is 3, and x does not divide by 4. Similarly with the x, if there was a coefficient of x here like a 8 that divided evenly by 4, I may divide that. And then if it was 8 divided by 4 there, I may write that as a 2x. Remember, the test is multiple choice. So you can look at the answers to help you, assist you in evaluating whether you've done the questions correctly. Question 3. So if the price of Arborview Math Camp price can be expressed as a function of days, what does the inverse represent? So here, the price can be expressed as a function of days. So this will be y, the price, is the y value. In other words, price is the output. And the input is number of days, x. For the inverse, we're going to switch the x and the y. In other words, we're going to put the number of days can be expressed as a function of price. Again, the test will be multiple choice. So you will be able to match this on the test with the wording. So number of days expressed as a function of price. Question 4. What is the composition? F, there should be an O or parenthesis here. It didn't get printed for some reason. I don't know what happened when I printed mine. There should be an O or parentheses. This should say FOG or FOG, or it should be F parentheses G of X. In other words, what this means is to put G of X in for X on F of X. It's a composition function. So the 2x plus 1 will replace the X here next to the 5 on F of X. So F of G of X, or FOG, will be equivalent in value to 5 times the quantity 2x plus 1 minus 3. I'll distribute the 5 to the 2x and the 1. It'll be making a 5x or 10x plus 5. And I'll take 3 away from 5 here to get to 10x plus 2. If this was written as GOF, it would go backwards. The 5x minus 3 would go in for x here next to the 2. Composition functions. And again, you can use FOG, or this is the same thing as saying F parenthesis G parenthesis X, F, the F of the quantity G of X, or the function evaluated at the quantity G of X. Composition. Question 5. Mrs. Meservey wants to transform the parent function f of t equals t squared. This is the same as f of x equals x squared. So if the variable is bothering you here, I'll just say it's the same as x. T and x are the same. Into the function f of x equals negative 2 times the quantity x plus 4 squared plus 3. Name the transformation she makes. So let's start with the left and right motion, the item next to x. X plus 4. This will move the function left 4. As again, we're looking to zero this out. We're looking to look at the vertex. So it moves it left 4. The x values are all moved to the left 4. Left 4. Next value here, the plus 3. This is a y, or vertical translation. This will move the function up 3. Next value here, the negative. The negative will reflect the graph on the x-axis. So normally a parabola will point upwards. In other words, y will increase in value as x increases or decreases in value. However, if there's a negative, it points downwards. And we call that a reflection on the on the x-axis, not the y-axis, the x-axis. X-axis reflection. Next item here is this 2. Again, the negative and the 2 are separate. The negative does the reflection. If it's a negative, it's a reflection. The 2 is separate from the negative here when you're considering what happens. The 2 is going to stretch the graph. In other words, it's going to double the y values for each corresponding x. So normally an x squared function is when x is 1, y is 1. When x is 2, y is 4 when we have x squared. But if there's a 2 here, it's going to double the y values. So instead of being when x is 1, y is 1, it'll be when x is 1, y is 2. Or when x is 2, instead of being 4, it'll be 8. So this is called a stretch by 2. Now if that value is fractional, it would be a shrink. So if that was instead of a 2, if it was a half, then it would be a shrink by 2. Shrinking representing the y values are shrinking. And again, that negative is separate from the number here when we're considering what happens. All right, question 6. Write a function that is stretched vertically and reflected in the x-axis as compared to the parent function f of x equals x squared. So stretched vertically will say that this will mean that this will have a coefficient greater than 1. So a 3x squared would be sufficient here, or 2x squared, or even a 1.1x squared would be sufficient to have a stretch vertically. I will use a 3x squared here. It also says it must be reflected in the x-axis. So this 3 will have to be a negative. It'll have to have a negative as a coefficient. This will be a function that is stretched vertically and reflected in the x-axis as compared to the parent. And I would write this one as f of x, or I could write it as g of x since it's a separate function from f of x. Or I could just say y is equal to. I'll just use y equals negative 3x squared. All right, next one, graph. F of x, or g of x, equals 4x squared. So this will be the same as your normal parabola, except that it will be stretched by 4. So in other words, then again, the test is multiple choice. So when you're matching these on the test, you will be matching graphs, not making them yourself, or constructing them yourself. So when x is 0, y is 0 here. When x is 1, instead of y being 1, y will be 4, because it's stretched by 4. 1, 2, 3, 4. And when x is negative 1, instead of y being 1, it'll be 4. Now again, this negative 1 squares is a quantity. So when I'm doing 4 times negative 1 squared, when I'm substituting negative 1 in for x here, what I mean is the quantity negative 1 squared timesing by 4. So it becomes a positive 1 as it's squaring, and then it multiplies by 4. Alright, so we'll just have to match the first 3 coordinates here to be able to match this on the test. In other words, the vertex, and then 1 to the left and 1 to the right of the vertex. Graph g of x equals negative 3x squared. This is very similar in nature to question B, except this one is reflected in the x-axis and has a stretch of 3 instead of 4. So I will do the same vertex. When x is 0, y is still 0 here. But when x is 1, y is now negative 3. And when x is negative 1, y is negative 3 as well. That negative coefficient again makes this reflected in the x-axis. And the 3 means it's got a stretch of 3. Now, when you're looking at these coefficients, these can actually be used somewhat similarly to slope, as we've talked about in the past. So we find the vertex 0, 0, since h and k are both 0 here, and then it's up 4 and over 1. So I can use this similarly to slope. Now again, it doesn't go up 4 over 1 for each step in the parabola. So it would be up 4 over 1, and then it would be up 3 times 4 over 1. So the next coordinate here would actually be up 12 over 1. So it would be at a value of 16, or 2, 16 would be the next value that would be plotted if I were to plot another value. And similarly here, it goes over 1, it goes down 3 and over 1 because it's like a negative 3 is a slope. But the next value would be 3 times that, so it would be down 9 over another 1. So that next value would be at 2, negative 12 for that next value if it was to be plotted on the graph. All right. And again, on the test, all you have to do is find the first 3 coordinates to match the graphs. It won't be trying to confuse you by giving you improper points 4 and 5 with multiple choice options here. All right, question 7. What are the factors of x cubed minus 64? This is a difference of cubes. Difference of cubes. On the test, again, it's matching multiple choice, so you will be able to look at them and perhaps distribute and match the proper answer. So the proper format here is this will be x, this will be x squared. X times x squared is x cubed. This will be a 4, and this will be a 16. And then what I usually do here is I pause and I try to think about what should be what in this particular one. So if this is a plus, then this will also be a plus. If it's a minus, then this will be a minus. So it is dependent on what that sign starts off as, plus or minus. So this will be a minus 4, meaning that this has to be a positive 16 because negative 4 and positive 16 are negative 64. Now in the middle there, the x term in the middle, you need to consider what is the value here in terms of its cube root. So the value here in terms of its cube root is a 4. So this will be a plus in this case. And it will be a 4x. It is useful to check your work. So x times x squared is x cubed. X times 4x, well, that's 4x squared plus 4x squared. X times 16 is positive 16x. Negative 4 times x squared is negative 4x squared. Negative 4 times 4 is negative 16x, and negative 4 times 16 is negative 64. Notice how all of the middle terms are opposites. 4x squared, negative 4x squared, 16x, and negative 16x. Sorry, the light just turned off here. So these will reduce out, leaving us with just x cubed minus 64, which is in fact the original item. So the factors of x cubed minus 64 are x minus 4 and x squared plus 4x plus 16. The quadratic here will not factor further with a cubic. So you do not need to worry about factoring this quadratic further. And on the test, again, because of the multiple choice functionality of the final exam, you will be able to look at the options and distribute and match this backwards if you so desire. All right, next question, the solutions. I'm asking you either to use the quadratic formula or to attempt to factor this. The option is up to you. Now, it may or may not factor on some of the questions. So if you are going to attempt to factor, don't spend your whole entire time attempting to factor this, because it may not factor. So a times c is negative 12. First times the last term. First coefficient times the last coefficient, the constant. So my goal here is to make a 1 from a negative 12. Well, I can do that if I use a positive 4 and a negative 3. So this one does in fact factor. The coefficient of x squared here is 6, so when I'm writing out the factors, 4 divided by 6 reduces into 2/3. So one of my factors should be a 3x plus a 2. And then negative 3 divided by 6 is a negative 1/2. The other factor should be a 2x minus 1. I can verify very quickly if this is properly done. 3 times 2x is 6x squared. Yeah, negative 2. Positive 2 times negative 1 is negative 2. Yeah. And then 3x times negative 1, that's negative 3x. 2x times 2x, that's 4x. Yeah, 4x minus 3x is in fact 1x. It asked me for the solution, so I'll set each of these equal to 0 separately. 3x plus 2 is equal to nothing. Therefore, 3x is equal to negative 2, and x is negative 2/3 is one of my solutions, or x-intercepts. As well as 2x minus 1 is equal to 0. So 2x will be equal to 1. Therefore, x is equal to 1/2 will be the other solution here. There will be two solutions to a squared or quadratic equation. Sometimes the solutions are complex, but there will be two solutions to every quadratic equation, provided that that solution is not 0, in which case there's only one solution if it's equal to 0, or if it has the discriminant equal to 0, I should say. All right, question 9. What are the solutions of x cubed minus 5x squared minus 9x plus 45? When there are 4 items, the question is asking us to factor by grouping every time there are 4 items. So I have group 1 and group 2. Group 1 has an x squared in common. They both divide by x squared. X squared times the quantity x minus 5. Group 2 has a 9 in common. They both divide by 9. I'll make this a negative 9 because this is the coefficient of x. It's got the negative there, and I want it to be positive so that it can match this other expression here, x minus 5. So I'll have here negative 9 times the quantity x minus 5. And now I have it factored. X squared minus 9 times the quantity x minus 5 is equal in value to 0. Here I'm going to solve this by setting each of these equal to 0. Now this one here is a quadratic. It does factor further. However, I don't need to factor it further. If I want to, I can set it equal to 0 here, add the 9, and then square root that value to get the value of x. Again, it does factor, so I could write that as x minus 3 and x plus 3 instead of solving it this way. Remember, this is equal to x is positive and negative 3. When you take a square root of both sides, you end up with a positive and negative value. And the other solution here, x minus 5 is equal in value to 0. Adding 5 to both sides is x equals 5. A cubic function will have 3 solutions, provided that 2 of those are not the same solution, just like the quadratic sometimes. If it has 2 of the same solution, when the discriminant on the quadratic is a 0, has two of the same solutions. Similar thing could happen here. But on the test, I believe it's 3 values as well. A cubic should have 3 solutions. What does the fundamental theorem of algebra say about the problem negative x minus 5x squared plus 6x cubed minus 5? It says it has 3 solutions. Why does it have 3 solutions? Because it is a third power, x cubed. What is the sum? Sum meaning to add the 2 items together. This is a complex number addition. We will add the real parts of the numbers. So 3 plus 5 is 8. And we will add the complex parts as well. Now the complex parts have opposite signs, so they actually subtract here because it's negative 2i plus 3i. But we will be adding the numbers together when we use the keyword sum. The keyword product, again, is to multiply. So if this says to product them together, we would multiply as a distribution or a product of binomials, the 3 by the 2, the 3 by the 3i, the negative 2i by the 5, and the negative 2i by the 3i. Anyway, it does say sum, so that's all we did here. Moving along. What are the roots? The roots are the same as the solutions. So I could just ask you for the solutions here, which I actually did on this question right here and right here. So this is the same thing once again. Now, I can attempt to factor this once again. So it may or may not factor. If it does not factor, I must use the quadratic formula to solve it. So a times c is 30. If I'm going to attempt to make a 4 from a 30, that's not going to work. Because 30 will be 15 and 2, or 3 and 10, or 30 and 1. But none of those can make a 4. So this right here will tell me right now, this right here tells me that this is not factorable. So I'm going to have to either complete the square or quadratic formula. I prefer the quadratic formula. Again, this is preference. Entirely preference. So x is equal to the opposite of the b value, negative 4, since the b value is positive 4, plus and minus the square root of the b value squared, 4 squared is 16, minus 4 times the a value times the c value, so 4 times 30. I'll write it as 3 and 10 separately here. All divided by 2 times the a value, 2 times 3. I'll write it as 2 times 3, and I'll change it to 6 in the next step. So now I'm going to have here negative 4, all this divided by 6, plus and minus the square root of 16 minus 120. And right here I can verify that these answers are in fact complex, as I originally thought about it at the start of the question, because 16 minus 120 is a negative value. It's a negative 104. So I have here negative 4 plus or minus the square root of a negative 104 divided by 6. I will need to take out the common factor here, and I will need to write this in terms of I because it's a negative root. So this root divides evenly by 4 26 times. Now why did I choose 4? Because the square root of 4 is 2. So I will take that and I will bring it out front, that 2, with the I signifying the root of negative 1. Since it's a negative root, it comes out. Underneath this root will be left at 26, because again, 4 by 26 is 104. 4 by 25 is 100, and another 4, 104. All over 6. And then these 3 items can reduce now. We don't reduce here in the step before because this root has to have a coefficient to be able to reduce with the denominator here. They all have to divide to be able to reduce, in other words. So 2 into 4 is, and the negative 4 is 2, 2 into 2 is 1, and then 2 into 6 is 3, which will leave me my finished answer. Now again, this is multiple choice. So when you're figuring this out on the test, you may not need to go the entire distance yourself. It may be sufficient for you to go a portion of the distance and be able to match the question. Move along. Question 13. The product means to multiply. So I'm going to multiply a by a squared. So a times a times bi, so that's minus, well, a times bi, well, that's abi. Next item is bi times a, well, that's abi as well, it's just plus instead of minus. And I can write it as bia if I want, or abi. It's the same because of the commutative property of multiplication. I'll write it as bia because it's bi times a, but it's the same thing as writing abi. So in other words, these two middle items are opposites, minus abi and plus bia. And then the final thing here is bi times bi. So that's minus bi squared, or minus b squared I squared. They do multiply together. It becomes b squared and I squared. So b times b and I times I. So these items in the middle are opposites. And what I really have to consider here is, what is b squared I squared? So this is a squared, and b squared is b squared, of course. It's a variable. I squared, however, represents a complex number times itself. It's a complex unit times itself. The square root of -1 times itself. So this becomes a -1. So that will change this sign into a plus, because a negative becomes a plus. So what does I squared mean? It means the quantity -1 squared. And when you square a -1, it in fact becomes a -1. It's the only number square, or I shouldn't say the only number. If you square a -4, it becomes a square root of -4 becomes a -4. But it's one of the numbers that when you square it, it becomes a negative. And that only happens when you have a root of a negative. So like if this was a square root of -4 squared, it would become a -4. Or a square root of a -9 squared would become a -9. The complex unit squared. It eliminates the radical, and it becomes a negative number. Question 14. The axis of symmetry of a quadratic function is at the line x equals 5. So this is the axis of symmetry. Again, I draw that with a dotted line. It represents where the quadratic, or it could be a fourth power, or the even power function, has symmetry with. So it can reflect across that line, and the points will be the same on either side. So I'm going to plot these points provided. 2, -12. Well, I guess I can't plot 2, -12. It's not on the grid. But I can plot 4, 4. 4, 1, 2, 3, 4. 5, 6. 5, 5, 6. And 7, -2. 7, -2. So I can plot those. And then I can extrapolate. Extrapolate meaning I can put, or not approximate, but get the other values here for this quadratic. So this value here that's on the axis of symmetry, this is the vertex. That is the vertex, the center of the quadratic. So everything will be centered around this point here, the point 5, 6. So in other words, this point here at 4, 4 is going to have its reflection here on the other side of the axis of symmetry at 6, 4. And this point here at 7, -2 is going to have its reflection along the other side here at 3, -2. So now let's look at the question. A student uses a table to approximate one of the x-intercepts at between 3 and 4. Well, yeah, of course it crosses between 3 and 4, because you look here, it's coming up and it's going through 3, -2 and through 4, 4. So yeah, that's one of its x-intercepts. And the question is asking, in what interval is the other x-intercept? Well, when it comes down along the other side, this value is 6 and this value is 7, it's going to cross through the x-axis again between 6 and 7. So my answer here is between 6 and 7. Between x equals 6 and x equals 7 will be the other x-intercept. And again, of course, the y value there would be 0 because it's an x-intercept. Question 15, difference of squares, factoring. So 36 is 6 squared, and 1 is 1 squared. This is a difference of squares. Again, if it was a sum of squares, it would not factor using the difference of squares. The difference of squares is a minus b and a plus b. So this will be 6x minus 1 and 6x plus 1. again, it's multiple choice, so you can match the question with the answer on the final exam by doing 6x times 6x, that makes 36x squared. Negative 1 times 1, that makes negative 1. 6x times positive 1 is positive 6x. And negative 1 times positive 6x is negative 6x, which would reduce out the middle items there. Which function has a greater y-intercept? The y-intercept is the constant on any parabola. So this is the y-intercept of negative 6. In other words, this is the coordinate 0, negative 6. This other function here has a y-intercept where it crosses the y-axis, and it just so happens to be an x-intercept as well at 0, 0. So which function has a greater y-intercept? The second function here. This function, g of x, because it crosses at 0 along the y-axis, whereas the first function has a y-intercept of negative 6. When you're looking at y-intercepts and you're looking at the constant at the end of the quadratic, or you're looking at the value of y when x is nothing, when x is 0, what is the value of y? All right, moving along. Question 17. What is the domain and range in interval notation of the given function? Domain, again, is our x values. So I'm asking here, what are the possible x values for this function? The arrows are pointing up and to the left and up and to the right. So it is pointing both directions for the x values, left and right. So the domain is unlimited. It has no limits. Negative infinity to infinity. The range, however, this graph does not point downwards. It only points upwards. So the range is limited by a minimum value. The minimum value here for the range is at negative 9. It does not go lower than a negative 9 for the y values. So in other words, the y values are all above negative 9. Now it includes negative 9 in its range here. So I will have a bracket instead of a parenthesis because I am including negative 9, and it points upwards from negative 9. Now if this graph was pointing downwards from negative 9, in other words, if it was flipped the opposite direction, then I would start, instead of with the negative 9, I would start with a negative infinity, and then this value here would be the negative 9 with the bracket if it was pointing downwards from negative 9. All right, graph the function. Negative x squared plus 8x minus 4. What is the vertex? We can find the vertex by doing opposite b over 2a, or by completing the square, or by attempting the factor and getting the x-intercepts. I will use opposite b over 2a since it's the easiest for me to remember. The opposite of b is negative 8, and then 2 times the value of a is 2 times negative 1, negative 2. So negative 8 divided by negative 2 is 4. This is the x value of the vertex. And it is also the axis of symmetry. X is equal to 4. So this will be centered at x equals 4. I always start off with the axis of symmetry. That's, again, personal preference. You may prefer to do this differently. Now I need to figure out what the y value is when x is 4. I can find that value by substituting x in, or I can find that value by again, completing the square and factoring. And this will give me the maximum on the function. So I'm going to do f of 4 here to get the y value of the vertex. So a negative 4 squared. Now this is not the quantity negative 4 squared. This is a negative after we've squared the 4. The 4 is positive. Plus 8 times 4 minus 4. So this is a negative 16 plus 32 minus 4. A negative 16 plus 32 minus 4. So that will be 12. The vertex is at 4, 12. So this vertex can't actually be plotted on the grid accurately, but it is at 4, 12. And again, I can use my calculator to assist me here. A negative 4 squared plus 8 times 4 minus 4. 12. That y value of the vertex is the maximum. Y is equal to 12. You can call it y equals 12 here, or just simply 12. And the y-intercept is at 0, 0, negative 4. The constant at the end of the function. This is a maximum because it's pointing downwards, negative. And because it's pointing downwards, it will have range equal to the maximum value pointing downwards. So it's going to be negative infinity, comma 12, because it's pointing downwards instead of upwards. And then again, the domain is unlimited. It's not possible to limit the domain of a quadratic unless said quadratic is a x equals y squared type, which we have not done yet. So the domain is always unlimited unless it's until next semester. Anyways, to finish this graph, it will point downwards, and it has this value at -4 as a y-intercept. So I'll plot that here, 1, 2, 3, 4, and I'll reflect it over on the other side. So this is 1, 2, 3, 4 to the left of the axis symmetry. It'll be repeated over here on the right side. The graph on the test will again be matching, so it'll be easier to evaluate. And I'm having issues graphing here because I can't hold the paper and talk on the mic at the same time, but hopefully you get the concept. Anyways, what I was saying is the graph on the test will be easier to match because you'll be able to look at it instead of having to actually plot the points, and it will plot nicely on the grid. It does plot nicely. All right, the area of the right triangle, half the base times the height. So the angle right here is 90. It's saying it's a right triangle. So I'm going to take half of 3x timesing by x plus 2. Well, half of 3 doesn't evaluate evenly. So I will multiply the 3x by the x plus 2 here first, and then I'll take half of that. So half of 3x times x, well, that's 6x squared. Notice I'm keeping the parentheses here. And 3x times 2 is 6x. 6x. 3x times x is just 3x squared. And then 3x times 2 is 6x. And then here I can take half of 6 to make it into a 3, but half of 3 is just, again, a improper fraction or a mixed number, depending on what it is to be matched on the test. So that's 1.5x squared plus 2x, or 3/2 x squared plus 2x. Alright, complete the square to write the equation in vertex form. Now, the test is multiple choice. So if you would prefer, you can actually do this question by finding the vertex and then matching the vertex to the finished answer on the multiple choice on the test. It is, again, preference. So if you would prefer to find the vertex, which is my preference, do that, and then just write it in vertex form with h and k. So I will use opposite b over 2a once again. The opposite of -4 is 4. And then 2 times 1 is 2. 4 divided in half is simply 2. So the h value here is going to be a 2. And then to get the k value, I'll substitute that back in. 2 squared minus 8. 2 squared is 4. Minus 4 times 2, which is 8. So 4 minus 8 is -4 plus 12 is 8. So the k value will be 8. So that is one of the options to match the question on the test. I do kind of want you to know how to complete the square because it's kind of a useful thing for algebra, or not algebra 2, for next year's material in the topics class and the college prep class specifically. So I am going to discuss how to complete the square here once again. However, on the test, if you just want to do opposite b over 2a and then figure out the y coordinate, that is acceptable because I will not be checking through all of the work. I don't have the time nor the desire. So to do the complete the square, again, you take half of b and you square it and add it and subtract it. And this is in fact not particularly more difficult than opposite b over 2a. It's just different. So I take half of -4, which is -2, and then square that quantity, which is 4. So I'm going to add 4. And subtract 4. And then this first part will now be a perfect square. It'll make that x minus 2 quantity squared that we have here. And here we have a -4 plus 12 like we were discussing just a minute ago. That's an 8. Either method is acceptable to get the right answer on the test. You may find the opposite b over 2a to be easier as you've done it more. The completing the square is in fact quicker though, and is in fact more more efficient. Moving along. What is the solution? Notice it says singular. Solution of x squared plus 3x minus 5 is equal to 0. So, I can attempt to factor, but 5 can't make 3. So I'm not asking you to factor here. I could attempt to complete the square, but this is an odd number. So completing the square here is probably not the best option. So the best option is definitely quadratic formula. So x is equal to opposite b, negative 3, plus and minus the square root of b squared. 3 squared is 9. I'll write it as 3 squared for now. Minus 4 times a times c. 4 times 1 times negative 5. All divided by 2 times a, 2 times 1. So underneath this radical, I will have a 9 plus a 20. Y plus 20, well, negative 4 times negative 5 is positive 20. So x is equal to negative 3 plus and minus the square root of 9 plus 20, all divided in half. Well, that is 29 when it all adds together. Negative 3 plus or minus the square root of 29 divided in half. This should have been a plural. Should have said solutions. We have a positive and a negative solution here on this question. Negative 3 plus the root of 29 and negative 3 minus the root of 29. And that 29 does not reduce because it is prime. So that root will not reduce. Graph the two functions. They both have the same y-intercept, negative 10. That's convenient. Oh, and it asked me here underneath, find the y-intercept of each. Negative 10. 0, negative 10. Find the vertex of each one. Well, these are going to have vertexes that are different. So these ones are going to be different in the values of their vertex. But they do have the same y-intercept. Same y-intercept. The question on the test here is asking you, how are the functions the same? Look at the number at the end. If it's the same, the constant here, that's the same y-intercept. If that number is not the same, then there may be something else that's the same about the question. Like, for example, the vertex. And the vertex would only be the same if they're both in vertex form with the same number here, with that here, and here. Or if the first one that's in the standard form could be completed, the square could be completed, or you could find the vertex by doing opposite b over 2a evenly. I am not going to graph both of these functions here, as all I'm asking here is what they have in common on the final exam. All right, which of the following has its vertex above the x-axis? So this is saying the y-intercept is greater than 0. So it's asking me which one has a y-intercept greater than value than 0. So this one here has a y-intercept of negative 3. This again is the y-intercept, so that's not the proper option. This one has a y-intercept at 2. That's a good option. This one has a y-intercept at 36 at the bottom. That's a good option as well. This one has a y-intercept at 0 and is on the x-axis, so it's not going to have its vertex above the x-axis, it's on the x-axis. So the y-intercepts on both of these are above the x-axis. However, I'm asking which one has its vertex above the x-axis as well. So the next thing I'm going to do is find the actual vertex of both of these. Well, here h is 0 and k is 2. So this is at 0, 2, its vertex. Here I don't have the vertex because it's not in vertex form. But I can convert it to vertex form very easily by either factoring this as a x minus 6 quantity squared, because a 6 by 6 is 12 and they're both negative, or by doing opposite b over 2a and finding the y value. So when I do this as x minus 6 quantity squared, you can see here, in fact, the vertex is on the x-axis. Negative 6, 0. All right, so again, what I want you to consider here is the y-intercept as well as the vertex. Now, the vertex is the actual question, so we are actually asking just for the vertex, but the y-intercept greater than 0 can give you a good hint on which one to start with, or which ones to start with, in terms of finding the value. And again, this one here is the k value of the vertex. This one's actually in vertex form, so I should have just wrote this one as a -1 comma -3 instead of circling the -3 here. Should have wrote it as its vertex is at -1 comma 3. Now the vertex here would be at 0 comma 0. H is 0, k is 0. All right, question 24. The standard form of a quadratic function, ax squared plus bx plus c, same as it's always been since quadratic forms were introduced. The characteristics below are those of the graph. So when the y-intercept is negative, so c is negative, c is less than 0, meaning that option A and B are inappropriate. And the zeros are at -4 and +2. So the zeros again happen when you substitute in that value for x, it ends up as y equals 0. So I can check either of these. I can check these and see which one happens to be when I put a 2 in, it ends up being a 0. So 2 squared is 4, 2 times 2 is also 4, 4 plus 4 is 8, and minus 8 is nothing. But here, -2 squared plus 2 times 2 minus 8, well, that negative applies after the squaring, so this is -4 plus 4 minus 8. Well, that would be a -8. So that's not a 0, that doesn't have a 0 at +2, nor at -4. This one does, though. -4 squared is 16, plus 2 times -4, -8, minus 8, yeah, that's 0. So option C is the appropriate answer here. Match the y-intercept first, and then substitute the value in for x and see which one yields a 0. Which one yields the proper 0. Question 25. The table lists all the real roots of a 6th degree polynomial, so this will be an x to the 6th power. What's the general factorization of the function? So I have here my first root, x minus root 2, so that's x plus the square root of 2. And then plus the root 2, so that's x minus the square root of 2. Remember, these roots always come in pairs. So there's a pair of roots, positive and negative root 2. The multiplicity 2 here means there's 2 of these. So instead of just being x minus 3, it's x minus 3 quantities squared. And again, the roots, or the zeros, are opposite from the factors. So when I'm saying x is 3 here as a 0 or a root, that's the opposite value of the factor. So that means it's x minus 3 squared. Same thing here with a -1. That's x plus 1 squared. These two roots would combine to make x squared minus 2. Root 2 times root 2 is root 4, which is 2. And then the middle items reduce out here. So I may have it on the test where it ends up being multiplied out here as x squared minus 2 times the quantity x minus 3 squared times the quantity x plus 1 squared. That is the factorization of p of x, the function. Alright, if f of x is a polynomial and f of 5 is 0, what can be concluded? So when I put in 5 for x, I should get 0 out for y, is what can be concluded here. When I put in 5 for x, I can get 0 for y. So in other words, the factor is x minus 5. Now notice it says x is not a factor and then is a factor. Well, it is a factor because when I put in 5, I get 0. If this is reversed and it says f of 5 is not 0, if it has a slash here, then option B would be the appropriate answer. X minus 5 would not be a factor if that has slash through it, like it had in the past. So in other words, the zeros and the factors are opposites. And if something is a factor, it will make 0 when you substitute it in. If it's not a factor, it will make something other than 0 when you substitute that number in for x. Question 27. Given that p of x is a polynomial of even degree, even, x to the second, x to the fourth, x to the sixth, with a lead coefficient of 4, so the coefficient of the first number is 4, which polynomial has the same end behavior? So I'm looking for an even polynomial. Even polynomial. So this is x to the second, third, fourth. This one is even. This one's 2, 4, 5. That one's odd. It's an x to the fifth. X to the second plus 2 plus 1, that's x to the fifth. 2, 3, 4. That's even as well. And then 2, 4, 5. That one's odd. So the B and D are both odd. Now I'm going to differentiate between A and C here using the leading coefficient. The leading coefficient of 4, that's a positive number. So in other words, this polynomial points upwards. So it's even pointing upwards. It points upwards. So in other words, it needs to be a positive leading value, not a negative. So C is the proper option. You can graph this on your graphing calculator if you have a graphing calculator, and you can verify which one points up and is even. Again, the even functions point either up, up, or down, down. They point only one direction for the y value. The odd functions point both directions, up on the left, down on the right, or down on the left, up on the right. Question 29. If x minus a is a factor, then when you divide that into the polynomial, the remainder should be nothing. The remainder should be nothing. This is again synthetic division, but we're not actually asking you to do synthetic division here. We're just asking you to consider if it's a factor, what's the remainder? Nothing. All right, consider the fourth degree polynomial. This is a fourth polynomial for a couple of reasons. First off, it points upwards, both directions. Second off, it has two relative max and minimum. Write a factorization that correctly represents the polynomial. So what I'm looking at here is the critical values here. The intercept specifically, -3, +2, and -5. As well as the maximum and the minimums. We'll discuss the maximum and minimums at the end though. So this crosses at x equals -3. That means it has a 0 at x equals -3. So this will be x plus 3, the factor here. And it's multiplicity 1 because it crosses. It doesn't bounce, but crosses. Then it bounces here at x equals 2. That's a multiplicity 2. That's x minus 2 squared because it's bouncing off of +2. And then it crosses again at x equals 5. So that's x minus 5. This is a fourth degree polynomial. 1, 2, 3, 4. Now I can check my answer by putting this into a graphing calculator and making sure that it has the minimum values at the relative minimum values at -1, -4, and +4, -1. I'm not going to do that because I don't have a graphing calculator at hand here. But this will be the correct factorization of the polynomial. You're looking at the zeros here, the x-intercepts, or the zeros or the roots, and you're figuring out if it bounces or crosses at that particular value to get the factors. Question 30. Given one 0, find the other zeros. We'll use synthetic division here. So since 6 is a 0, I can divide this evenly into the polynomial. The coefficients here are 1x cubed, 2x squared, -20x, and +24. Now I have to be careful here whether I'm using a +6 or a -6. So it says 6 is the 0, -6 is the 0. So I should in fact be using a -6 here, not a +6, because +6 would be the factor. In other words, x plus 6 would be the factor. -6 is the 0 or the x-intercept, in other words. So I'll change that to be the proper item. Alright, so the 1 comes straight down. -6 times 1 is -6. 2 plus -6, or 2 minus 6, is -4. -6 times -4 is +24. -20 plus 24 is +4, and then -6 times 4 is -24. And again, my remainder is in fact nothing, as we talked about in the previous question. If it is in fact a 0, when it divides in, it will have nothing as a remainder. Or if it's a factor, x plus 6 is the factor here, when it divides in, it will have no remainder. Alright, so this is the remaining items, which represents an x squared, a -4x, and a +4. Again, it decreases the function's value by 1 when you divide it using synthetic division. So x squared minus 4x plus 4. And then what I'll do to finish this question to find the other zeros is to factor this out. 2 and 2 make 4 when they multiply, and if they're both negative, they can make a -4x. So this will be x minus 2 x minus 2 equals 0. And this actually only has one other 0 at x equals 2, because x minus 2 equals 0. So it actually only has one other 0. It would have 3 zeros a cubic, but 2 of them are the same here. Two of them are both x equals 2, because of that quadratic in the end factored with a square. All right, question 31. 4, 6i, and 3 minus the square root of 2 are zeros of a polynomial with real integer coefficient. What's the minimum degree? Again, these complex roots always come in pairs, so that means that it's going to have at least another one there. So this right now it's a third degree polynomial. It's got 3 zeros, but this is always going to be coming in a pair. So 6i and negative 6i come in a pair there, and then the roots, they also always come in pairs. So 3 minus the square root of 2 should have its counterpart as well. So this will in fact have a minimum degree of 1, 2, 3, and then these ones we count twice, 4 and 5. Minimum degree of 5. The integers sometimes come as single solutions, like this one here. X minus 2 is used twice. But the roots and the complex numbers always come in pairs. All right, choose the function that correctly represents the graph. So this has a y-intercept at negative 4. So I'm looking at this for a y-intercept at negative 4. When x is 0, y is negative 4, and I don't actually have the proper equation here. That is an issue. So you should be able to match the y-intercept, and then you should be able to match which direction it points as well. It's pointing up on the left and down on the right, so this should be a negative x cubed minus a 4 when we're matching this on the final exam. On the final exam, the questions have already been worked through, and it doesn't have this particular mistake on there. All right, question 33. The volume. The volume of in this case, a right prism, triangular prism, is given by the area of the base times the height. Well, if the height is x plus 2, and I want to find the area of the base, I can divide this into v of x. So in other words, I'm going to take this, divide it into that. I'm going to use synthetic division, though. So that the factor here is x plus 2. Negative 2 is the 0 or the root. Using the coefficients of 3, 10, 6, and negative 4. And this should divide evenly, because again it's said that it was a root. So negative 2 times 3 is negative 6. 10 minus 6 is 4. Negative 2 times 4 is negative 8. 6 minus 8 is negative 2. Negative 2 times negative 2 is 4, and yes, it has a remainder nothing. So again, this decreases in power by 1 when we divide synthetically. So this will be a 3x squared plus 4x minus 2. That will be the base, the polynomial expression for the area of the base. B equals. All right. Question 34. Write which function has the following graph. We're going to again consider the starting value here. It's at 2, 5. That is not called the vertex on a root function, but it is similar to the vertex, so it goes with h and k. So again, with the root functions, we have y is equal to a times the square root of x minus h plus k, just like with a parabola or quadratic function, and h and k represent the starting value. So 2 and 4. 2 is h and 4 is k. I do have to consider if there is an a value here. So to consider if there's an a value, I look at, again, the increase. It goes up 1 over 1. So this has an a value of a 1. If it had gone up 2 and over 1, then I would put a 2 here as the coefficient. If it had been up 3 and over 1, I would have put a 3 here. The fractional coefficients we did not consider. when we were doing these questions here. So you do not have to consider them for the final either. Solve. We're going to square root both sides to start this question. So 4x minus 1 is equal to, well, when I square root 36, I get the number 6, but I also get the number negative 6. Because when a square root is done to both sides of an equation, to both sides of an equation, it yields a positive and a negative answer. So I'll add 1 to 6. So x should be 7/4. I will also add 1 to negative 6, which means x is negative 5/4. I can verify my answer using the calculator by substituting the value in for x and seeing if it squares to make 36. So I'm relatively positive on the positive value that it's a solution, as you should be as well, because that's the solution that you should be able to get. The negative value I'm not quite as sure on. So perhaps on the test, if I'm not sure on that negative value, I will do 4 times the quantity negative 5/4 as a fraction, because it's a fractional value, negative 5/4, minus 1. And when I square this value, I'm thinking that it makes 36. So does this value squared make 36? It does. So yes, it is negative 5/4, one of the other values. Again, you can use a calculator as well here to assist you in matching the questions based on the answers as well in the test. Identify the domain of the function in interval notation. A cube root function does not have a split domain. Only a square root function does. So this is all real numbers. I did say use interval notation, so I should write this as negative infinity, comma infinity in interval notation. Only a square root function has split domain. So if that had been the square root of x minus 2, then I would have wrote my domain as 2 comma infinity, including the 2, not including infinity, of course. All right, describe the graph, describe the transformation. So this is right 3 because it's x minus 3. Minus 3, again, we do opposites. We're making that 0, so it's right 3. And it's up 2 because of plus 2 at the end. If there were a coefficient in front, then that would mean it would have a stretch or a shrink. If this was a 4 in the front of the root, not the index, but the coefficient of the root. So if there was a 4 as the coefficient of the root, we would say it is stretched by 4. Question 38, range. I'm asking here which direction it points and where does it start. So it starts at negative 5. And does it point upwards or downwards? It points downwards because the coefficient is negative here. There's a negative in front. So it points downwards from negative 5. Downwards from negative 5. Negative infinity, comma, negative 5. Points downwards from negative 5. Again, if that was a positive 3, then I would switch this around and it would be positive infinity on the right side here and negative 5 on the left. It would be negative 5, positive infinity. If that was a positive 3, because then it would be pointing upwards instead of downwards. Question 39. Consider the piecewise defined function. Evaluate f of negative 1 plus f of 1. So when we put 1 in for x, it should go into the bottom function. So f of 1 is equal to 1 minus 1, which is in fact 0. So f of 1 here happens to be nothing. When I put negative 1 in, it should go into the top function. F of negative 1 is 2 times the quantity negative 1 squared minus 3. So this is 2 times 1. Negative 1 squared is a 1. So that's 2 times 1 is 2, minus 3 is negative 1. So f of negative 1 is in fact negative 1. And because I'm adding 0 to it, because f of 1 was 0, I can just leave it as a negative 1 here in this case. All right, using the graph, find h of 1 plus h of negative 1. h of 1 is the function's value when x is 1. So at 1, y is negative 2. h of negative 1 is the function value at negative 1. This open circle means that that's not the value to use when x is negative 1 there. Use the value with the closed or the filled circle. So h of negative 1 is also negative 2. Negative 2 plus negative 2 is negative 4. My answer here. All right. And that concludes our review. Again, the final exam is multiple choice, and it does have, instead of 40, 50. We've gone over the 50 questions here. It's just they're divided up somewhat differently on the final exam. At least I think it's 50 questions. It might be 40. But we've gone over all the questions here from the final exam. Come in after school if you want to discuss the questions further. And thank you for watching the video.